All right, so we have looked at what happens when you plug a value in and get like sine and cosine. So if you have a function and your x and y is like the plugging in of the angle and then your answer is what you get, okay, then we've done that. The sine of 30 is 1/2, all right? And so if you think of it in terms of that, theta being the input, or your x value on the horizontal axis, and y being your output or the actual answer to the trig function, the ratio you get, then you can graph it. Now, if you think about a circle, the unit circle, when we do that, we are just saying, okay, what creates the point on the circle? What are those x, y values, right? And we have a circle. But if you were to split those up and say x gives me a y, x gives me a y, and now we're not talking about sine and cosine, we're talking about theta, input of the angle, sine is output of the function, then you create a different looking graph, all right? And so the circle is just a way to represent your sine and cosine values. Your sine and cosine values based on right angle trigonometry. You can take each one of those functions. You can take the sine function, you can take the cosine function, and you can actually graph it out on an xy coordinate plane. All right. And so when we look at it this way, we are not talking about the sine value being the y and the x being the cosine. We are talking about input versus output function. And the first function we're looking at is the sine function. And so our input of the function is going to be the angle. Sine of what angle? The output is going to be the answer. Now you can use your unit circle to answer that. If I said, what is the sine of 60? Input would be 60 degrees. Output would be square root of 3/2, okay? But we are now talking about input being your angle, output being your y value, all right? Now, this has it in degrees. I will say that like 99% of the time, you're going to have it in radians, all right? And so when you get a graph from me, like you see at the bottom of this page, you're going to notice that your x coordinates are in terms of radians, all right? You're going to see pi over 2, pi, 2 pi, all right? Those still represent numbers. Pi is 3.14, and goes on infinitely. It's still a number on your x-axis, but it is going to be in terms of radians, all right? And so when you get graph paper from me, it will be in terms of radians, not in terms of degrees, all right? But they've shown it to you in terms of degrees just to graph it, all right? So for the sine function, if you have your unit circle, you may want to get that out. They have this particular one in terms of degrees. So on your unit circle, if you have 0, that's my input. What is your output? What is the sine of 0? All right, so you'll notice my input was 0, so my x value is 0. X meaning input, I'm not talking about on the unit circle. Output was 0, so I plot 0, 0 right here. All right. If I look at 90 degrees, 90 degrees is my input. What's my output? Y. What's my sine value? 1. And you'll see that we plotted a point right here at 1. 180 degrees, what's my sine value? 0. See, we're back at 0. 270, that's down at the bottom. -1. And then back to 360. We have cycled, okay? We have one cycle. So what is one cycle of the unit circle? What's one period of the sine value? 360 degrees. It's also 2 pi in terms of radians, all right? So in terms of radians, this would look like this. 0, this would be pi over 2. This would be pi. This would be 3 pi over 2, and that would be 2 pi, all right? So one period then of your sine function is going to be 2 pi. It takes 2 pi for it to complete an entire cycle, which makes sense because that is how long it takes to complete an entire circle as well, all right? And so it starts here at 0. It goes up to 1. What does 1 represent? Well, is 1 also on this? If I were to ask, I could ask another question. What would 1 be for this?
90 degrees.
It would also be amplitude. Everybody agree? You're 1 away from your middle. So we started at 0. We went up to our amplitude. We went back to 0. We went down to as far as our amplitude would let us go down, right? Distance away. And then we went back to 0. And that is your sine function, and that's how your sine function will always cycle, by the way. So when you're visually looking at a graph, it's really easy to see what your amplitude is. You just figure out where the middle is and you count up or count down, right? Or you count from highest to lowest and divide by 2, all right? For sine and cosine functions, this is always the same. Your amplitude will be represented by the coefficient of the trig function itself. So if you have a number that is in front of your trig function, that will be your amplitude. That will be how far it moves up and down. So when we had just y equals sine of theta, the number in front of sine was 1, and that was my amplitude. All right? And so for your sine and cosine functions, your amplitude will always be represented by the letter A. And it determines how far the graph goes up and down from the midline. This is what we call the middle of our graph, the midline. All right? The midline. Period. The standard sine graph, how long did it take for a standard sine graph to complete one cycle? 2 pi, right? 360, one circle. All right? You can also look at it when this is in standard form. This is considered standard form. Y equals some number times sine of something plus something. So this is the format you're going to see it in, just like you would see a quadratic in ax squared plus bx plus c. It's standard form, okay? Another way to look at the period is to take that 2 pi, because that's where you start, and divide it by any number that is multiplying the input. 2 pi over b. This is actually an absolute value, by the way. The period's always going to be positive. All right, because you're talking about how long it takes to do something. How long it takes to do something is not going to be negative. Negative indicates direction. So when we start shifting left to right, up and down, we'll have positives and negatives. But for amplitude and for period, it is absolute value. So it is always positive. It's always positive. And period determines how long it takes for the graph to complete one cycle. So again, you look at this just regular old sine graph that hasn't had any changes to it. What number is in front of theta? Well, it's a 1. There's a 1 in front of theta if you don't see a coefficient. So it makes sense that the cycle of just a standard sine graph would be 2 pi. All right? So here we have our standard sine graph, y equals sine of theta. The best way to do this is to break this up into fourths, all right? So you figure out where your starting point is. In this case, my starting point is going to be 0. The next thing you figure out is how long the period is. The period is where this cycle is going to end, right? And start over. And so my standard one is 2 pi. So it means it should end the cycle right here. So you want to figure out where you're going to start, mark that one, and you want to figure out where you're going to end, mark that one. All right, you have your starting and ending of one cycle. Now, you're going to divide it up. Divide it in half, wherever the halfway mark is for that. In this case, it's going to be pi, because this is a standard one. And then you want to divide it in fourths, which means you want to divide each of those sections in half. In this case, pi over 2 and 3 pi over 2. And so you have your starting, your first quarter, your halfway mark, your 3/4 mark, and your ending mark, okay? And then it will follow the same exact pattern every time, all right? You will start at your midline. Wherever your midline is, you will start. The first quarter for a standard one is going to go to the highest value, which is your amplitude, right? In this case, my amplitude is 1. So however far away from the midline you can get, your first quarter will go there. You will be at your farthest point from your midline. You will be at your amplitude. Your halfway point will always go back to your midline. In this case, 0. Your 3/4 will always go to the lowest point. All right? It will go to the lowest point that your amplitude will allow you to go. And then you will always end back at your midline. This is a standard sine graph. All right? And so if you learned it in quadrants, we're going to learn the same thing for cosine. You'll be able to graph them, starting and ending, and then know how far away from it you're going to get. So let's look at one of them. Let's look at this first example here. All right, so the first thing I'm going to do here is I'm going to figure out what my period is. All right, that's going to give me a little insight into how much of this graph I really need to use. So amplitude and period, I'm going to figure out those. And then I'm going to figure out my quarter marks and mark them. All right, so what is my amplitude here? What is the absolute value of A? 1/2. 1/2, which means I am going to go up 1/2 and down 1/2. That's as far as I will go. Period is going to be 2 pi over what?
1.
What's in front of my theta? 2. So my period's going to be what?
Pi.
Which means instead of taking 2 pi to cycle, it's going to take 1 pi to cycle. All right? And so I'm going to do this, and I'm going to just stretch that out just a little bit so we can see it a little better. All right? And I'll actually crop it so we can still see. So that means I really am only going to use a little bit of this graph. All right? And I don't even need these markers here. All right? So now I'm going to mark my beginning, my ending, and my halfway and quarter marks, all right? So I'm going to start here, right? And I'm going to end here. If my ending is pi, where's my halfway mark? Pi over what? 2, right? So, and on these, you can sketch it if it's not on there. So that is my halfway mark, right? Where's my first quarter then? Pi over what? 4. Oh, it's going to be a little bit like this. All right. And what's my 3/4 mark?
3 pi over 4.
And so I have all of that sketched, right? Now I start at 0. My first quarter, I go up to my amplitude. So where am I going up to?
1/2.
1/2. So I start here, I go up to 1/2. My halfway point, I'm back at my midline, which is where?
0.
3/4, I go down to -1/2. Oh, that's not 3/4. 3/4 is here. And then I end where?
Back at 0.
Back at 0. And then you just sketch it. You just draw your curve. You want to go past it with an arrow, because it is a cycle. It's going to keep going. But that is a cycle of pi, period of pi, amplitude of 1/2. Period of pi, amplitude of 1/2.
I'm still kind of confused on how you get the period.
All right.